Well, Duke, thank you so much for sitting down with me.
Absolutely, Mark.
This week is the National Association of Plant Breeders annual meeting here in Ames, Iowa. I'm in Ames for the meeting. You were unable to make the meeting, but that's okay because we have this great technology that we can use to still do our interview during the meeting. And so thank heaven for technologies like this so we can still connect. Now, you are incoming chair for the Plant Breeding Coordinating Committee, which actually founded the NAPB. Can you tell us about the PBCC, what it does, and what you see as its primary function in the plant breeding world?
Sure. So PBCC was formed in 2006, as you mentioned, and it was largely formed out of the state experiment stations from land grant universities. And this was done in partnership with NIFA, the National Institute for Food and Agriculture. So specifically, we are a multi-state activity versus something like a professional society. And I just kind of want to lay these out because when I started grad school and I went to this meeting and they were talking about NAPB and PBCC, I was like, what's the difference? Um, and so there's a few difference. Mainly, membership is through the form of each state nominates a representative that's approved by the state agricultural experiment director. But we are open to anybody. You just have to ask. We love having more people. As we build the community, more input always makes for better decisions. So yeah, in about 2009, PBCC started the National Association of Plant Breeders, and there's some differences. I guess I just wanted to highlight, and I'll talk more about this. But kind of our primary activity is more about coordinating the activities around plant breeding in terms of common problems, messaging that we want to get out. And this is in contrast to like NAPB, which is more about scientific exchange regarding plant breeding, so new findings, research, as well as advocating for plant breeding technology. And then, like any professional society, like recognizing awards, individual accomplishment, things like that. Some of the other things that are different in terms of the recommendations that we make as a committee. Really, we can only provide input to land grant university leadership as well as USDA leadership, as well as state and federal agencies. One of the key distinctions is we can't give our opinion to Congress unless asked. And so NAPB strategically was spun off as more of like, I don't want to say the lobbying arm, but having that direct mouthpiece with congressional representation because, as we move forward, as an organization, we knew that we needed that kind of, mouthpiece to talk more with like legislators and the things that are people that are enacting change and whatnot. Um, so the other thing is that NIFA can talk to us directly to solicit input because we are a federally recognized organization representing plant breeding stakeholders. They can come to us directly, whereas with NAPB, they can only solicit input in a very like open public format so that everybody has the ability to kind of provide their thoughts and feelings. And so with our primary function, really, I would say, it sounds lame, but to coordinate. Basically, we have 50 states. Every state's agriculture is just a little bit different. So it's trying to like get everybody on the same page to identify, what are the problems, what are the challenges we're facing, and how do we basically organize ourselves to be effective in addressing them. So I think another component of that is awareness. So getting this information out to the broader public. Um, there's a disconnect right now in American society between like agriculture and consumers. And if you ask, they did this study where they talked to kids about where they thought, milk came from. And they're like, well, the grocery store, like where else would it come from? And so I think that's kind of one of the other things is just kind of like the awareness issue. And so as a coordinating committee, like trying to get our resources aligned so that we can generate solutions to specific problems, but also, to generate positive impacts. Not everything's a problem, but bringing community awareness to some of the challenges that we're facing. And so I think, that's kind of one of the key things about PBCC is, identifying, coordinating, and moving forward as a community to address larger issues. So in kind of that capacity, that's how we provide feedback to our stakeholders like the Ag Experiment Station directors, federal agency, things of that. And so again, I guess our primary function is to really elevate issues that need to be brought to the national attention and then to organize effectively to help, generate positive impact for society, specifically, with plant breeding. And I would say like our biggest role is communication. That's really key is making sure that people understand the issues that we're trying to address, but also to listen, to understand what growers are facing and things that they're after. And so I think that's kind of, if I had to sum up PBCC, that's how I would frame it.
Now, as a somebody who's involved in the plant breeding world, I'm sure you have plenty of things to do. What made you want to add this to your agenda? What made you want to lead the board of the PBCC?
My personal involvement began with this when I was a graduate student in 2011. I helped found the graduate student working group of NAPB. And so sounds lame again, but it was just like this family. It's a small community, and I've known all these people since I was a grad student. And so they've helped me tremendously in my career. I was serving on those committees, even post, graduation from grad school, still stayed in contact. They're people I work with on a regular basis. And so it's just the sense of community and just recognizing that, you've benefited from it and it's always important to give back. A lot of the past chairs are some real big names in plant breeding, and frankly, I was pretty humbled that I was selected. Obviously, I'm a little bit early career, so I found it like to be a really unique opportunity to kind of just give back to the organization that's given so much to me. And then on a broader level is just trying to have some good mark in terms of like plant breeding and representing our community and I don't know improving agriculture in the public's eye too.
What for you is the biggest challenge, biggest, most pressing agenda item for the PBCC right now?
I would say it is communication. I think right now we're in a pivotal time in our society. Through better or through worse, we have high inflation. People for the first time are recognizing that food has a cost. And we've been fortunate in the past to not really have to pay attention to that. Like students in my class, I always ask them how much of their budget they think they put towards food, and nobody ever says more than 10%. And I always contrast that with other countries where it's 30 to 50%. And so, tragically, some of these issues are brought about by inflation or the conflict in, Ukraine and whatnot. But I think it's a really pivotal time because all of a sudden, I think America's kind of getting back to its roots and thinking about reinvesting in agriculture. Climate change, we see it happening, we see the impacts of it, and we're starting to feel it in our pocketbooks. And I think that brings an inherent amount of natural attention to the topic. And so I think for us as an organization, as much as we can do to promote plant breeding as a sustainable solution to some of these challenges, is really what I would like to see our organization accomplish in the next year. I think it'd have a lot of impact, and frankly, I think it's very timely and it's needed.
So, Duke, can you talk a little bit about your research program? What exactly are you studying?
Absolutely, thank you, Mark. So I'm based in Arizona, and it's hot and dry here, all the time, always. And so I often say that Arizona has the climate of tomorrow today. And so my research program is focused on the genetics of abiotic stress tolerance and specifically heat and drought. And so we use multiple crops. So to date, my lab's worked on 15 different crops, everything from vegetables to row crops. The ones that we're primarily focused on are cotton and sorghum. Um, and so I'm focused on kind of the basic science aspect of trying to identify the genes and alleles that confer tolerance to these kind of harsh conditions. And so my group uses a lot of high throughput phenotyping, so using drones. But I'm also very fortunate to get to use the world's largest agricultural robot. It's called the UA Field Scanner. This was built by the Department of Energy. It's a fully autonomous robot that covers about 2 acres of land and basically sits there and images plants around the clock throughout the season. Um, and so we're using that type of technology in conjunction with like artificial intelligence, machine learning, to truly try to understand, what makes some plants more tolerant to stress than others. And I would say that's kind of the key focus of my research program is just really trying to understand, how water is used for plant growth besides the obvious, but how do we manage that? How do we make plants economically productive with less water? Kind of these kind of future climate scenarios that we're facing in, 10 to 15 to 20 years.
Yeah, well, and speaking of future scenarios, your team received a grant to help you better communicate with plants. That was pretty cool. I know it was mentioned in the media quite a bit. And can you talk a little bit about that? It just sounds fascinating.
Sure. So it's part of a NSF Science and Technology Center. It's in partnership with Cornell University, Illinois, Boyce Thompson, and University of Arizona. And kind of the idea is, um, what would happen if we could talk to the plants? So plants, unlike animals, right? They can't get up and move away from hot or cold or walk to food, and so they're really resilient organisms because they have to deal with what's handed to them where they're at. And so when we talk about like communicating with them, it's really trying to get this back and forth conversation of like me as if I was a production farmer, it's like, well, what do you need, plant? And having the plant be like, hey, I'm a little low on nitrogen, and if you could give me some water, that would be great. And I know not to like trivialize or anything, but kind of getting that back and forth to change kind of the management strategy. So, you know, right now I would say most of crop management tends to be on the reactive side. So we see a pest, a problem, and we seek to address it. Whereas if we can communicate with plants, it kind of shifts the paradigm to being proactive. The plant telling us what it thinks it might need. So that's kind of the grand vision for the project. Um, Additionally, it's just kind of this idea of if you could talk to the plant, what type of new research could you do? And so one thing that we've been really interested in is like what happens when we remove like natural constraints on the plant. Um, and so, plants, close their stomates in response to heat and drought. Well, what happens if we had a plant that didn't and it just left its stomates open? Like, where does the system break? And so that's kind of like the really exciting area of biology is finding out what the limits are and why those limits exist. Because if we can understand those, we have a better idea of how we can potentially, work with or modulate to achieve a new outcome that maybe wasn't naturally possible. And I don't want to talk about like frankenfoods or anything, but just kind of tweaking nature to push the boundaries a little bit and maybe address some of these larger issues like making plants more water use efficient or nitrogen use efficient. So it's a really fascinating grant. There's a lot of cool technology. We're talking about robots that can swim through the soil and basically like sample root tissue for us. Small, very like microscopic, nanoscale sensors for measuring like water potential in the leaves. So it's just a really fascinating project to bring together like engineering, the plant biology, to really like move the needle in terms of plant science. I think that's why it's so exciting is all this stuff you have thought about, like, well, if I could just do that. And it feels like for once in our careers, like that barrier is being broken down a little bit to be like, oh, well, let's try that. Let's do that. So that's a really cool project. And thanks for asking about it, Mark.
No, no problem. And yeah, thanks for telling us about it. And thanks for your time, Duke. And it's been a great week here at NAPB and look forward to getting the information out. And thank you so much. It was nice to meet you and have yourself a great day.
Pleasure to speak with you as well, Mark. Talk to you later.